Dr. Benitex here. Let's talk about stoichiometry calculations. Starting with question number 1. From the question, we can see that sulfur dioxide reacts with oxygen gas to form sulfur trioxide. Before we can even attempt this problem, we have to write a balanced equation for this reaction. So we have that sulfur dioxide SO2 combines with oxygen gas O2 to produce SO3. Let's balance the equation next. So to balance this equation, we are going to add a 2 as a coefficient here and a 2 as a coefficient here. From here, we can see that the equation is now balanced. For more details on balancing of chemical equations, do well to check out my previous videos on balancing of equations, as can be found in the description. Let's solve the A part of the question that says, if 3.4 moles of sulfur dioxide react with excess oxygen gas, how many moles of sulfur trioxide will form? From this question, we can see that the stoichiometry here connects sulfur dioxide with sulfur trioxide. Anytime you are being told that a particular reactant is in excess, is a clear indication that the amount of that reactant will not be provided and you don't need it for your calculations. Now, let us solve the problem using molar interpretation. From the balanced equation, we can see that 2 moles of sulfur dioxide SO2 produced 2 moles of sulfur trioxide. What does that indicate? That indicates that the given 3.4 moles of SO2 will also produce 3.4 moles. But let's do this from the mathematical perspective. So we are going to cross multiply. So you're going to have that 3.4 multiplied by 2 divided by 2 moles of what? SO3. So the final answer here is going to be 3.4 moles of SO3. But let's go back to the question. Says, if 3.4 moles of sulfur dioxide react with excess oxygen gas, how many moles of sulfur trioxide will form? We got that. This is our final answer. Let's now go to the B part of the question. The B part, this is the A part. Let's go to the B part of the question. The B part of the question says, how many moles of oxygen gas will react completely with 4.7 moles of sulfur dioxide? Let's figure out what the B part is connecting. Now we can see clearly here that the B part of this question is striking a connection between sulfur dioxide and oxygen gas. So from the balanced equation, we can see here that 2 moles of sulfur dioxide will always react with 1 mole of oxygen gas. Let's go back to the question. The question says, how many moles of oxygen gas will react completely with 4.7 moles of sulfur dioxide? So 4.7 mole of sulfur dioxide will react with, will cross multiply. 4.7 multiplied by 1 divided by 2. 4.7 multiplied by 1 divided by 2. And that's going to give us 2.35 moles of oxygen gas. Final answer. So this indicates, or this implies, that 4.7 mole of sulfur dioxide is going to react completely with 2.35 moles of oxygen. Now let's solve problem number 2. Problem number 2 talks about propane gas reacting with oxygen to form carbon dioxide and water. The equation for the reaction goes like this. We have propane C3H8 combines with oxygen. This is a combustion reaction. And the product here, we have carbon 4 oxide CO2 and we have water H2O. First things first, let's balance the equation for the reaction. So to balance this equation, we are going to start by comparing. Carbon is 3, carbon is 1. So we have to put a 3 as a coefficient. Carbon is balanced. Next, let's balance hydrogen. Hydrogen is 8, hydrogen is 2. So to make it 8 on this side, we multiply by 4. We're adding 4 as a coefficient. Now we have balanced all the atoms except oxygen. On the product side, we have 3 times 2, that is 6 atoms of oxygen plus 4 atoms of oxygen, making it 10. While on the reactant side, we have only 2. So to make it 10, we have to put 5 as a coefficient here. And that multiplies this to give us 10. Now that we have a balanced equation, let's start solving from the very first problem. The A part of the question says, if 2.8 moles of propane react with excess oxygen gas, how many grams of carbon 4 oxide will form? This stoichiometry connects propane gas to carbon 4 oxide. And remember, we are given 2.8 moles of propane. So we can solve this problem by using the molar interpretation, after which we are going to convert our final answer to grams. Let us do this. So from the balanced equation, we have that the coefficient here is 1, meaning that 1 mole of propane C3H8 will react to always produce 3 moles of carbon 4 oxide. That is what we have from the balanced equation. We are given 2.8 moles of propane. So how many moles of carbon 4 oxide is expected to form from 2.8 moles of propane? So we are going to cross multiply. So 2.8 multiplied by 3 divided by 1. So we have 2.8 multiplied by 3 divided by 1. That will be moles of CO2. And this is going to be equal to 8.4 mole of CO2. Remember, the question is asking us how many grams of carbon 4 oxide will form. So we have to convert the moles back to grams. Using the formula, number of moles is equal to mass over molar mass. Now we are looking for the mass, so we're going to cross multiply. So therefore, mass is going to be equal to number of moles times the molar mass. So mass is equal to number of moles is given as 8.4 from our calculation. And I'm multiplying by the molar mass of carbon 4 oxide, which is 44. We know that carbon is 12. 12 plus 16 times 2, which is 32. That gives us 44. So we say 8.4 times 44. So our final answer here is going to be 369.6 grams. 369.6 grams of CO2. Now we are done with the A part. Let's go to the B part. So the B part says, how many grams of oxygen gas will completely react with 3.8 moles of propane? So you can see that the B part of the question connects propane and oxygen gas. So we are first going to use the molar interpretation to solve this problem, after which we convert our answer back to grams. Why? Because the question says how many grams of oxygen gas will completely react with 3.8 moles of propane. So from the balanced equation, we can see that the coefficient of propane here in the balanced equation is 1. So therefore, 1 mole of C3H8 always reacts with how many moles here? 5 moles of oxygen gas. So that simply implies that the 3.8 moles given to us is going to react with. So 3.8 moles of propane is going to react with. We are going to cross multiply, and that will be 3.8 here multiplied by 5 divided by 1. moles of oxygen. This is going to be equal to 19 moles of oxygen gas. But remember, the question says that we should find how many grams of oxygen gas will completely react. So we are going to convert the moles of oxygen gas to grams of oxygen gas. And how do we do that? We do that by multiplying the number of moles here by the molar mass. Remember the initial formula I gave you, where you have number of moles is equal to mass over molar mass. Alright, so from there, we can see that the mass of oxygen gas is going to be equal to 19 moles of oxygen gas multiplied by the molar mass of oxygen is 16 times 2, which is 32 grams, presenting 1 mole of oxygen gas. So moles of oxygen gas cancels moles of oxygen gas. Our final answer is going to be 19 multiplied by 32, and that will give us 608. So that's equal to 608 grams of oxygen. Let's go to the C part of the question now. For the C part of the problem, we have that if 25 grams of propane reacts with excess oxygen, how many moles of water will form? So this question here connects propane and water. So we have propane and we have water on this side. So based on the nature of the question, we are going to use a mass interpretation. What do I mean? We are asked if 25 grams of propane. So it simply means we are going to be using masses for our calculation. But in the end, we are going to convert our final answer to moles because we are required to find the moles of water that will form. So let's use the mass interpretation. From the balanced equation here, what is the molecular mass for propane? Carbon is 12. So 12 times 3 gives us 36. 36 plus 8 sums up to 44 grams. So we have that from the balanced equation, 44 grams of propane will always react to produce. The molar mass of water is 18. So 18 times 4 is 72 grams of water from the balanced equation. Now, 25 grams of propane is expected to give us what? It's expected to give us 25 multiplied by 72. I'm going to be dividing this by 44. We're going to know the exact amount of water in grams that will be produced from this reaction. So we solve this and it's going to give us, that gives us 40.91. So we have 40.91 grams of water. But the question is asking us how many moles of water will be formed. So we're going to convert this to moles. And how do we do that? We're going to divide the mass we just got by the molecular weight of water. So therefore, the number of moles of water is equal to 40.91 grams of water divided by the molar mass of water, which is 18 grams per mole. And this is going to give us about, that'll give us about 2.27 grams of, sorry, not grams this time, it's going to be 2.27 moles of water. Final answer, 2.27 moles of water. Let's go to the D part of the question now. So the D part of the question says, if 38 grams of water are produced in the reaction, how many moles of CO2 are produced? So the stoichiometry here connects the CO2 alongside the water. Now we are going to use a mass interpretation for this particular question, after which we now convert our final answer to moles. From the balanced equation, we are going to convert this to grams. We know that carbon is 12, hydrogen is equal to 1, and oxygen is equal to 16. So we have that carbon is 12, so 12 plus 32 gives us 44. 3 times 44 is about 132. So from the balanced equation, we have that 132 grams of carbon 4 oxide will always be produced alongside water is 18, we know that one. So 4 times 18 is 72. We produce alongside 72 grams of water according to the balanced equation. So therefore 38 grams of water, when it is produced, how many grams of CO2 will be produced alongside 38 grams of water? We are going to cross multiply. So it's going to be 38 times 132 divided by 72. So I have 38 times 132 all over 72 grams of CO2. So when we calculate this, it's going to give us about 69.67 grams of CO2. So we are going to convert the grams of CO2 here to moles, because the question is asking for how many moles of CO2 will be produced alongside. So how do you convert this to moles? You have to divide by the molecular weight of CO2. So therefore, number of moles of CO2 will be equal to 69.67 grams over 44 grams per mole, and that's going to give us equal to 1.58 moles of CO2. Final answer. So we are done with question number 2. Let's go to question number 3 now. So for question number 3, we have that aluminum reacts with chlorine gas to form aluminum chloride. So we have to write a balanced equation for the reaction. So we know that aluminum, Al, is in group 3 and it has a charge of 3 plus. And we know that chlorine is in group 7 and it has a charge of minus 1. So let's write a balanced equation for the reaction. Aluminum, Al, combines with chlorine gas, that is Cl2, to produce what? Now we need to find the formula for aluminum chloride based on the information we have above. So the correct formula for aluminum chloride is going to be, the 3 goes down here. Now the magnitude here is 1, the 1 goes down to this side. So the correct formula for aluminum chloride is going to be AlCl3. Let's now balance the equation. Now how many atoms of chlorine do we have? 2. How many do we have here? 3. So we can balance it possibly. How do we balance it? I can use LCM. So 2 here, 3 here. LCM of 2 and 3 is 6. So I have to make it 6 here and make it 6 here. So I'm going to put a coefficient here, 3. I'm going to put a coefficient here, 2. So my chlorine atoms are 6, 6 on both sides, while my aluminum is 1. I have to put a 2 here as a coefficient, and that is the balanced equation. Now moving forward to solving the A part of the question that says, if 35 grams of aluminum react with excess chlorine, how many grams of aluminum chloride will form? From this question here, we can see that the stoichiometry connects aluminum with aluminum chloride. We're going to use a mass interpretation for this problem. Don't forget that aluminum, Al, is equal to 27, while chlorine, Cl, is equal to 35.5. These values are what we must know before solving this problem. So from the balanced equation here, we can see that 2 times 27 is 54. 54 grams of aluminum will produce, okay, let's get the mass here. Aluminum is 27 plus, so we have 27 plus 35.5 times 3. And I'm going to multiply everything here by 2. That's the mass of AlCl3. Let's do it together. Alright, so let's harmonize all the calculations we've done so far. So we can see that 54 grams of aluminum will produce 267 grams of aluminum trichloride, or you can say aluminum chloride. So let's now solve the problem properly. So the question is asking us, if 35 grams of aluminum reacts with excess chlorine, how many grams of aluminum chloride will form? So 35 grams of aluminum is expected to produce how many grams of aluminum chloride? We are going to cross multiply. 35 grams multiplied by 267 divided by 54. 35 grams multiplied by 267 grams all over 54 grams of aluminum chloride. So what will be the final answer here? Let's punch it out. So that gives us 173.06 grams of aluminum chloride. That's the final answer for question number A. Let's go to the B part now. Okay, the B part of the question says, how many grams of chlorine will react completely with 42.8 grams of aluminum? So the B part of the question connects aluminum with chlorine. So let's solve it using the mass interpretation. So from the balanced equation, we have that 2 times 27 is 54. We have 54 grams of aluminum will always react with. Let's find the mass of chlorine here. So we have that chlorine is 35.5. So 35.5 times 2 is 71. So 3 times 71 will give us 213 grams of chlorine gas. So from the question is asking us, how many grams of chlorine will react with 42.8 grams of aluminum? So if you are given 42.8 grams of aluminum, how many grams of chlorine will react with that? So we are going to cross multiply. So 42.8 multiplied by 213 divided by 54. So 42.8 multiplied by 213 all over 54 grams of Cl2. Let's solve this problem. So that gives us about 168.82 grams of Cl2. Final answer. So this is the amount of chlorine gas that will react with 42.8 grams of aluminum. Okay, now let's solve problem number 4, which says nitric acid is manufactured by the Ostwald process, in which nitrogen dioxide NO2 reacts with water according to the equation shown here. How many grams of nitrogen dioxide are required in this reaction to produce 7.5 grams of nitric acid? Let's balance the equation with the reaction. So we are given that NO2 plus water, H2O, is going to give us HNO3 plus NO. Alright, so from here, let us balance the equation because it's not balanced. How many nitrogen atoms are here? Remember, don't forget, if you want to balance an equation, first balance those atoms that appear once on both sides. You can find these rules on my video which talks about balancing of chemical equations, which I'm going to leave the link on the description. So let's move on to balancing this equation. So I'm not going to balance nitrogen first. Let me balance hydrogen, because hydrogen appears once here and also appears once on this side. So I'm going to balance hydrogen. So how many hydrogen atoms are here? I have 2. How many are here? I have 1. So I'm going to put a 2 here. So putting that 2 there, I have altered the number of nitrogen here alongside oxygens. So let's now balance either nitrogen or oxygen. Let's start with nitrogen. How many nitrogen atoms are here? I have 2 nitrogens here present. I have plus 1. That's how many? 3. How many on this other side? I have just 1. So I'm going to put a 3 here. That will balance nitrogen. Let's now balance oxygen. How many oxygen atoms are here? 3 times 2 is 6, plus this one 7. What about here? 2 times 3 is 6, plus 1 7. My equation is completely balanced. Now let us solve the problem. The problem is asking us, or the question is asking us, how many grams of nitrogen dioxide, that is here, is nitrogen dioxide, how many grams of nitrogen dioxide are required in this reaction to produce 7.5 grams of nitric acid? So the equation, or let me say this stoichiometry, connects the nitrogen dioxide to nitric acid. So let's use a mass interpretation to solve this problem. Nitrogen is 14, N is equal to 14, O is equal to 16, H is equal to 1. So we are going to have that 138 grams of NO2, because that's the sum of the masses here, is going to produce, the sum of the masses here is going to be 126 grams of HNO3. Now the question is asking us, how many grams of nitrogen dioxide are required to produce 7.5 grams of HNO3? So 7.50 grams of HNO3 produced by, we're going to cross multiply. 7.5 multiplied by 138 divided by 126. So I have 7.50 times 138 all over, times 138 all over 126 grams of NO2. So let's work that out, and that's going to give us about 8.21 grams of NO2. Final answer. So this is Delight Imperial Coaching. I am Dr. Benitex, always here to solve all your chemistry problems. Do well to like this video, do well to watch this video till the end, and do well to share this video with your friends who are having difficulties on chemistry. So in our next video, we are going to be talking about calculations on limiting reagents. So it's going to be titled Limiting Reagent Problems. See you there.